All right, so we're going to start this second topic video just looking at our examples. I've given us two, and the directions, if this were a worksheet, would say explain the end behavior. So maybe I should write that up here. Explain the end behavior of each polynomial. And I want to show you how easy this can be. So the information in the chart may look a little bit convoluted, and I don't want you to think that it has to be a long process to figure out what end behavior is. Remember that we said in our notes that there are two things that are important to us when we discover end behavior. One is the degree of the function, and one is the leading coefficient. I'll just say LC, specifically whether or not it's positive or negative. So let's look at example number 1, and let's find the degree and the leading coefficient. Keep in mind that in order to find that, it's helpful to put the equation into standard form, meaning that it's in descending order from the highest power down to the lowest, ending with just the regular coefficient, or just the regular constant term, the regular number. So here we actually have, in example 1, fourth power, third power, squared power. This is technically a first power, x to the 1, plus 4. So this is already in standard form. So I can go to my first term and say, what is the degree? Well, the degree is 4. That's the degree of the function. And I can say, what is the leading coefficient? Well, the leading coefficient is the number out front of the highest power, the variable with the highest power. So 10 is our leading coefficient. And the most important thing here is that we have a positive 10. So here's what this means. Our graph of this crazy polynomial, 10x to the 4th plus 3x cubed minus 4x squared plus x plus 4, is quite simply going to behave like an even, to see the degree is even, an even positive power function. Kind of like a positive x to the 4th. That's what it's going to behave like. Remember that even power functions are a parabola, and if it's positive, it starts high and ends high. And the end behavior for this will be exactly the same. We will say it will start high, end high. And that's it. For example number 1. That's all you have to do to answer what end behavior is. And really, it's just behaving like this highest leading term with the degree and the positive coefficient. Let's try it again, just so you can be totally convinced at how easy this is to figure out. Second polynomial example, unfortunately, is not in descending order. It's not in standard form. We have a constant term first, and then we have 8th power, 9th power, first power, second power, 5th power. It's all out of order. So let's see if we can rearrange it. We find the highest power first, which appears to be the 9th. So we'll write the whole term, 8x to the 9th. Next one will be minus 10x to the 8th. Next one will be minus 7x to the 5th. Then squared, plus 3x squared. Minus x, 4x, minus 4x, plus 5. That's our constant term. I have all the same terms. I've used them all, but I just rewrite them into descending order. Okay, now we ask ourselves the question, what is the end behavior? We need to know two things. We need to know the degree and the leading coefficient. So let's look at our leading term. The degree is 9. That makes it an odd function. And the leading coefficient is positive 8. So the degree is 9 and the leading coefficient is positive. That means that our polynomial is going to behave like an odd positive function. Kind of like a cubic, not position, that's funny, positive, odd and positive. That means it's going to look like this, just like a regular cubic graph that we talked about, because it's odd, like x cubed is, but it's positive, so it it starts low, ends high, as opposed to the other way around, starting high and ending low. In other words, this is going to behave like positive x to the 9th. Starts low, ends high, and that's what the end behavior will be. Start low, end high. Oops. All right, that's it for the example of how to find end behavior in a polynomial.